Ancient counterweight engineering in siege weapon design. Ever wondered about the true giants of the ancient world? Not mythical beasts, but the colossal machines that shaped history. How did ancient civilizations manage to hurl massive stones with such devastating force? How did they project these destructive payloads across vast distances, often with surprising accuracy? We are talking about siege weapons, the ultimate instruments of ancient warfare. These were not mere tools. They were engineering marvels. These were weapons that could level the mightiest castles, shatter the strongest walls, and break the will of entire armies. But how was such incredible power harnessed? Let's dive deep into the ancient world, a time when raw ingenuity met the brutal necessities of warfare. It was an era where survival often depended on technological superiority. Today, we are cracking a code that has fascinated engineers and historians for centuries. We are unveiling the profound secrets of counterweight engineering. Our focus is specifically on its application in siege weapon design, a field where physics and destruction converged. This is where the principles of leverage and gravity were weaponized. First, picture this, the Trebuchet. It stands as perhaps the most iconic and formidable siege engine ever conceived. It was a colossal machine, often towering several stories high, a true testament to ancient ambition. Its singular purpose was destruction on an unprecedented scale. Its mission was to launch projectiles with immense power. Think not just boulders, but flaming incendiaries, pots of Greek fire, or even diseased carcasses designed to spread terror and plague. Truly nasty stuff. But how did such a massive, seemingly simple device achieve such devastating results? The secret, the very heart of its power, lay in its ingenious use of counterweights. Imagine massive weights, often hundreds or even thousands of pounds, typically crafted from stone, lead, or even packed earth. These were the engines of destruction. These colossal weights were suspended on one end of a long, sturdy arm, often a massive timber beam. This arm was the lever, the conduit of power. The other end of this formidable arm held the projectile, cradled in a sling. This was the payload, waiting for its violent journey. Here's where the magic truly begins. The counterweight is released. With an unstoppable force, gravity takes over, pulling the immense mass downwards. The arm swings with incredible velocity, a sudden, violent arc of power. The projectile, held fast until the precise moment, is then launched with terrifying speed and range. It seems simple, right? But the true genius lies in the details. This wasn't merely about brute force, though there was certainly plenty of that. This was about precision engineering, a sophisticated understanding of mechanical principles. Ancient engineers were not just builders. They were applied physicists. They understood the fundamental laws governing motion and energy. They knew about leverage, the mechanical advantage gained by using a lever. They meticulously calculated angles of release, trajectory, and the optimal weight ratios. They mastered the art of controlled destruction, turning raw materials into instruments of strategic impact. Every component, every measurement, contributed to its effectiveness. Think about the sheer logistics involved in constructing such a machine. Hauling those massive counterweights, often over difficult terrain, was an immense undertaking. Building the towering frame, ensuring its structural integrity against immense forces, required advanced carpentry and joinery. Ensuring stability during the violent launch was paramount. It was a monumental feat of engineering, a testament to human ingenuity under the most extreme pressures. It showcased an incredible blend of theoretical knowledge and practical application. Now, let's talk about the profound impact these weapons had on warfare itself. They didn't just change battles. They redefined the very nature of conflict. Castles, once considered impregnable bastions of defense, suddenly became vulnerable. Their thick walls, once a symbol of security, could now be systematically dismantled. Sieges, which could drag on for months or even years, became significantly shorter. The psychological impact alone was often enough to break a defender's resolve. Battles became deadlier, more decisive, and often more terrifying. The trebuchet introduced a new level of destructive power to the battlefield. But here's a crucial question that still sparks debate among historians and engineers. How did they perfect the design? What were the iterative processes? What were the immense challenges faced by these ancient engineers? How did they overcome material limitations, structural stresses, and the unpredictable nature of battle? What specific innovations emerged over centuries of trial and error? How did they refine the balance, the release mechanism, and the projectile's trajectory? The trebuchet is just one magnificent example of counterweight engineering in ancient warfare. There were other counterweight weapons, each with its own unique design and purpose. Each of these machines, from the smallest to the most gargantuan, has its own fascinating story to tell. Each represents a chapter in the history of human innovation and conflict. So what other ancient technologies or engineering marvels truly fascinate you? What forgotten secrets do you believe are still waiting to be uncovered? Let me know in the comments below. And join us next time as we continue our journey through the incredible history of human ingenuity. We'll be exploring, well, you'll have to wait and see.